You are listening to SDO Isabela Radio-Based Instruction.
Learning never stops in Math Eskwela, your school on air.
Your partner in achieving fun learning experiences. Let's listen, enjoy, and have fun in learning mathematics. Stay tuned.
Good morning, grade 5 pupils. This is your School on Air in Mathematics. We are happy to be with you in our lesson in this medium of instruction. I am your radio teacher, Sir Hiros W. Torres. Batang Isabelino, are you ready? Make your ears active. Think well and relax. I am your handsome radio teacher for today. But because you cannot see how handsome I am, I will let you hear my handsome voice for all handsome and beautiful children of Isabela. Sa Isabela, walang batang maiiwan. At this moment, kindly get your learning kits in mathematics bag. Do you have your learning kits with you now? That's great! Before we start, let us review first our past lesson. Are you ready? Okay, let's start. What is our last topic all about? That's right, rounding decimal numbers to the nearest hundreds and thousands. So class, what did you learn in our past lesson? Great! We learned the different steps or points how to round decimals. To round decimal numbers, first, you have to determine the rounding place and the digit to the right of the rounding place. Next, the digit in the rounding place is the one that will either be rounded up or rounded down depending on the digit on the right. If the digit to the right of the rounding place is 5 or greater, add 1 to the rounding place, while less than 5 means retaining the digit in the rounding place. Another, do not forget to drop all the digits after the rounding place. Now, will you try to answer this problem? Venus is sometimes called Earth's twin. The speed at which Venus revolves around the Sun is about 35.012 km per second. Round this to the nearest hundreds. Round this to the nearest hundreds. So what is the answer, class? The answer is 35.1. I think you are now ready to start another lesson. Well, that's great. We will begin our new discussion in a while. Today, we are going to tackle comparing and arranging decimal numbers. At the end of this episode, you will be able to compare and arrange decimal numbers in descending or ascending order. Now, class, I think you are now ready to start our new discussion, isn't it? All right. Class, to compare decimal numbers, we need to align first the decimal points and the digits in their corresponding place values. Begin comparing the digits with the same place values from the leftmost digits. Use the symbols greater than, lesser than, or equals. in comparing the digits in the same place value. Decimals are arranged on either increasing or decreasing order. Ordering decimal is similar to ordering whole numbers. In common use, a decimal refers to part of a whole number. The numbers to the left of a decimal point represent whole numbers, and each number to the right of a decimal point represents a fractional part of a power or 1/10. For instance, the decimal value 1.24 indicates 1 whole unit, 2/10, and 4 hundredths, and that is commonly described as 24 hundredths. For ordering decimals, certain rules are followed. First, given a number of decimals, to order them, we first line them vertically so that their decimal points are exactly one above another. For example, if we have numbers 3.05, 0.23, and 1.746, and we're going to align them with each other, then digits 3.0 and 1 are aligned with each other, as well as 0, 2, and 7, and 5, 3, and 4, while 6 in 1.746 isn't aligned vertically with any other digits. Second rule: if a number does not have a decimal point, we place the decimal at the end. We are talking of a whole number for the second rule. Suppose we have 2, 35, and 113. Before arranging them based from their decimals, we can write them as 2.0, 35.0, and 113.0. Zeros to the right do not change the size of decimal numbers. Notice though that sometimes the zeros are very important, as they are placeholders and keep other numbers in the correct place. Zeros to the right do not their uses though, as well as helping us compare values. They can indicate how accurately something has been measured. Third rule: more number of digits in a number does not necessarily mean it is a bigger decimal number. For example, 0.42 is bigger than 0.416. 2.62 is bigger than 2.1778. And 134.12 is bigger than 134.108. Let's proceed to number 4. Zeros are added to the right of the decimal numbers so that all of them have the same number of decimal places. Let's have examples. 2 is the same as 2.000. 34.24 is the same as 34.240. And 256.3 is the same as 256.3000. The fifth one: the digits with the same place value are compared starting from left in all the numbers. And the numbers with a bigger digit, the same place value, decides the bigger decimal number. Let us have an example. Compare the decimal numbers by writing from least to greatest. The numbers are 1.54, 0.5, 1.501, 1.7, and 2. I repeat, the numbers are 1.54, 0.5, 1.501, 1.7, and 2. In comparing decimal numbers, all we need to do is to line up the decimal points and the digits of the numbers. 1.54, 0.5, 1.501, 1.7, and 2 in their corresponding place values. Then we compare the digits. We compare the digits in the same place value. We compare first the ones digit. Most of them have the same value except for 0.5 and 2, which has 0 and 2 on its ones digit respectively. Since 0 is lesser than 2, hence 0.5 is the smallest and 2 is the highest. Did you get it, class? Great then! Next, we compare the tens digit of the remaining 3 decimals. Since they already have the same ones digit, we have number 1.54, 1.501, and 1.7. Since 1.5 is lesser than 1.7, 1.7 is the greatest among the 3 decimals. But we need to compare 1.54 and 1.501. We compare the hundreds digit. Since they already have the same tenths digit, so we have 1.54 and 1.501. Now class, which is greater between 1.54 and 1.501? That's right, 1.54 is greater than 1.501. Now we can write the numbers from least to greatest. Hence we got 0.5, 1.501, 1.54, 1.7, and 2. We got 0.5, 1.501, 1.54, 1.7, and 2. To better understand the concept of our lesson today, let us try to answer questions based from this problem. I will read it to you, so listen very well. Peter was asked to cut 5 pieces of wire, each one as possible to 15.125 centimeter in length. A record shows the length of the pieces Peter cut. Which piece is the shortest? Which piece is the longest? I repeat, which piece is the shortest? And which piece is the longest? The first cut is 15.182 centimeter. The second cut is 15.147 centimeter. The third cut is 15.087 centimeter. The fourth cut is 15.097 centimeter. While the fifth cut is 15.18. I repeat, the first cut is 15.182 centimeter. The second cut is 15.147 centimeter. The third cut is 15.087 centimeter. And the fourth cut is 15.097 centimeter. While the fifth cut is 15.18 centimeter. I will give you 10 seconds to answer the given questions. Now class, would you mind to tell me which among the 5 cuts of wire is the shortest? How about the longest? To do that, first we need to arrange the numbers in ascending order. Therefore, the arrangement the numbers will be 15.087, then 15.097, followed by 15.147. Next is 15.18. And the last one is 15.182. Again, we have 15.087, 15.097, 15.147, 15.18, and 15.182. Now, my dear learners, which among those 5 cut is the shortest? That's right, the third cut, which is 15.087. How about the longest cut? All right, the longest cut is the first cut, which is 15.182. Did you get the same answer, class? Congratulations! Let's have another problem. Are you ready? All right. Candice uses a ruler to cut 3 different size ribbons. One is 6.5 inches long. One is 6.25 inches long. And the other is 6.75 inches long. She decides to order the ribbons from smallest to largest. Without seeing her ribbons, the only way to determine the order is to arrange the measurements from least to greatest. What is the order of the ribbons? If the ribbons are 6.5 inches, 6.25 inches, and 6.75 inches long, how can they be arranged from least to greatest? First, add zeros to make the digit numbers equal. Hence, we have 6.50, 6.25, 6.75. Next, compare the numbers without the decimal to determine which is greater. In the problem, 6.75 is greater than 6.50, and 6.50 is greater than 6.25. Then, list the numbers in order from least to greatest. Therefore, you'll get 6.25, 6.5, and 6.75. Candice ribbons are arranged with the 6.25-inch ribbon first, then the 6.5-inch ribbon, and the 6.75-inch ribbon. All right, class. That ends our discussion. Remember, to compare 2 decimals, start at the left and compare digits the same place value position. It is helpful to write 1 decimal below the other. It is also easier to compare decimals when you have the same numbers of decimal digits. Thus, when comparing two decimals, we can write one or more extra zeros to the right of the last digit of one decimal, so that both decimals have the same number of decimal digits. Another tip, it is easier to compare if the numbers have the same amount of decimals. You can tag a zero or zeros to the end of the number with less decimals. Did you understand, class? That's great! I think you're now ready to take a short quiz. Now, I want you to prepare your quiz pad and pen. We will begin your quiz in a short while. For this quiz, we are going to test your knowledge on comparing and arranging decimals. I'm going to give you 5 sets of decimals. For each set, determine what decimal is the lowest and what decimal is greatest. I repeat, determine what decimal is the lowest and what decimal is greatest. Did you understand, class? For number 1, we have 15.09, 15.90, 15.009, and 15.909. I repeat, for number 1, we have 15.09, 15.90, 15.009, and 15.909. Next, number 2, 26.006, 26.606, 2.606, and 26.060. I repeat, for number 2, 26.006, 26.606, 2.606, and 26.060. For number 3, 404.04, 40.404, 4.404, 404.4. I repeat, for number 3, 404.04, 40.404, 4.404, and 404.4. For number 4, 54.06, 54.6, 54.64, and 54.61. I repeat, for number 4, 54.06, 54.6, 54.64, and 54.61. And finally, for number 5, 3.87, 3.087, 3.875, 3.807. I repeat, for number 5, 3.87, 3.087, 3.875, and 3.807. Answer it now, class. We will reveal the correct answer after a while.
Halina't matuto, gamit ang ating radyo, pakinggan at unawain, aralin
I think you are now ready to know the correct answer. Am I right? Well, be prepared for we will reveal them now. For number 1, the least decimal is 15.009 and 15.909 is the greatest. How about number 2? You got it. The least is 2.606 while the greatest is 26.606. Let's proceed to number 3. Alright, the least decimal is 4.404 and the greatest is 404.4. How about the answer for number 4? That's right. The least one is 54.06 and 54.64 is the greatest. Now, for the last number. That's it, class. The least is 3.087 and the greatest is 3.875. Did you get them all correct, class? I know you did. Give it up until the next episode. By the way, congratulations everyone. Keep answering other exercises in your learning kits to further hone your skills in comparing and arranging decimals. If you have any queries about our lesson today, feel free to contact your teacher on the phone number included in your learning kits. Your teachers will wait your text message about your modules. Just send it to the number placed on your kits. You can also send by an email or just message through Facebook or other social medias. Make it sure that you will always tune in to our School on Air every Monday to Friday. Once again, I am Teacher Hiro W. Torres. Study hard, do good, and good life will follow. Before we end this episode, we would like to acknowledge the scriptwriter, Sir Jeremy T. Gilbaliga, for his continuous dedication and unparalleled service for our learners. We would like also to thank the RBI production team and to the whole SDO Isabela for their support and for making this production possible. Again, thank you very much.
Patuloy ang edukasyon para sa ating henerasyon.
Sa daan ng pagkatuto ay walang may iwan.
Kaya halina sa Radyo Eskwela!